Here's another, excuse me. Here's another quadratic equation. The way we know, highest power of the variable is 2. That's what makes it a quadratic equation. It's not in standard form, which is the form I want when I'm going to apply my solution methods. So let's put it in standard form. Now, I don't want to move the x squared term. I want to keep the coefficient of the x squared term positive. So I'm going to move these two terms over to be with the x squared term. And I would do that by subtracting 2x from both sides and subtracting 4 from both sides. And now I have a quadratic equation I can solve. It's in standard form. All three terms are there, so let's use the formula to solve this equation. Opposite of b, that's going to be positive 2, plus or minus the square root of b squared. The square root of negative 2 is 4, minus 4 times a is 1, times c is negative 4, all of that divided by 2 times a. 4 minus a minus is plus. 4 times 4 is 16. So x equals 2 plus or minus the square root of 20 over 2. And the square root of 20 I can break apart into the square root of 4 times the square root of 5. And the square root of 4 is 2. Broke apart the square root of 20 into the square root of 4 times the square root of 5. Square root of 4 is 2. Now, each of those terms are divisible by 2, aren't they? So I can distribute that division. 2 divided by 2 is 1. 2 times the square root of 5 divided by 2 just leaves us the square root of 5. And here are our two solutions to that quadratic equation, which we solved by using the formula. After we put it in standard form, which makes it possible then to correctly identify the a, b, and c coefficients that we use in the formula.